Hello everybody, my name is Alberto and I am a game developer. In today's Unity tutorial, I want to talk about how to create complex logic through data in the editor. Regardless if you're using your own data implementation or scriptable objects or even mono behaviors, the idea is to see here how we can create complex logic here in the inspector and interact with any part of our system's architecture. In the past videos, we've seen that the creation of the different systems is done systematically in the initialize method, and any dependency is passed via the constructor, enforcing a specific order in its creation. However, how we can then interact outside this scope with the different systems? Well, this can be done through the public methods that are available in our system group. We can request a system using the try get system method over here. You also need to think about this method as get component from the mono behavior is a method that you will not call in every frame in update because it has a cost in performance. We've also added some security to this method through the access type enum. If the system is not public, we are not going to be able to get access to it. Okay, then let's dive into the example I wanted to show you. And for that, let's go back to the inspector. Over here, we have our example data, and I've added two new parameters. One about here is called move up speed. This is just going to be our testing example, and we're going to see something happening in the screen. Our capsules that we were rendering in the past video are going to start moving up at some point. And this some point is going to be when this condition over here is met. This might seem pretty straightforward, but this condition over here can become very complex, and that's what I want to show you over here right now. Let's then move on to the implementation of our condition system. We start with this simple interface where we check if the condition passes or not. We also created an interface for a condition data, and this is what we've seen in the inspector. And this pattern will be used in many of our data types. In this case, what we are doing here is deserialize our condition data into a condition, and we're passing something that we call source. And we'll see why it's interesting to know who is actually deserializing this condition data into the condition that we are actually going to use in our runtime. But before moving forward, we'll need to have in our project an attribute which we can call subclass selector property attribute, which will allow us to serialize these interfaces in the inspector. I'm not going to go in detail in the implementation of this property attribute, but what we are mainly doing happens over here, and we are just checking that any class which is assignable from this interface or is a subclass of the target type that we are aiming. With this, we can select any implementation of our interfaces. Perfect. Let's now move to our next necessary implementation, and it is this comparison. Okay, trust me, this seems to have no connection with the condition, but we're going to use everything together, and you will see that everything will come nicely together to make a complex logic in our implementation of that condition. But here we're doing exactly the same. This is a comparison, and we're also checking if the comparison passes or not. And we are gonna follow the same pattern. We are going to deserialize the comparison data into our comparison. Okay, let's now move to our first connection. Well, we can actually make a condition which we are going to call comparison condition. And this condition will have a comparison. And what this condition is going to do is to check if the comparison passes or not. This is how we are going to connect the first part. And here down, we see why do we need this condition data interface? Well, over here, we are going to create a comparison condition data, which is going to be the class that's going to be serialized in the inspector. And over here, we are going to need a comparison, and we're going to need to use the subclass selector property. And remember that when we are serializing interfaces in this way, we need to serialize the reference, not the value. We are serializing a reference, and I can show you later how this looks in the file that is created, in our case, in the scriptable object. You will see that this file talks about an RID, and it talks about a reference to some object. It's not the same, and this needs to be clear when you're working with, in this case, interfaces and not directly a value. Finally, in our deserialize method, we are going to create our comparison condition, and this is quite interesting because what we do over here is to deserialize our comparison data into the comparison that is required in this structure over here. And that's basically it. And that's quite simple thing. So let's see what we can do with this. Well, we basically need to start implementing some comparisons, right? We want to use a comparison in that comparison condition. Here I show you some examples of basic comparisons that you want to have in your game, but these ones are actually meant to be used in the code and not in the editor. And we are going to see why, and then we are going to see which one we want to use in the editor. This over here, it's basically equal to comparison. For example, it implements the incomparable interface, and we are passing the value and to which value we want to compare to. We are passing these two things in the constructor. And when we check if it passes, we compare one to the other. So this comparison is going to be all the time the same the moment the instance of this object has been created. But as you can see, I'm actually using a structure. I'm not using a class because this is meant to be used during runtime several times. You can maybe want to be creating these comparisons and be performing these comparisons over different frames. But they are not meant to be used in the editor because then would be no point to just set by yourself what is the value and what to compare to, right? And that brings me to the last implementation, which is going to be the value getter. This value getter is going to return as a value. And we are going to follow the same pattern as before, and we are going to have data that we will deserialize into the value getter. But as you can see here, we need to know this type. And you cannot serialize in the editor something that the compiler still doesn't know what it is. So we need to define them. And here I'm putting some examples. And this could serve for a integer value getter, for a Boolean value getter, for a floating, or for a vector tree, or for whatever you want. You just implement it over here. And let's now move to the most interesting part of this talk. What do we do with this getter? Well, we can make a comparison that instead of requiring a specific value, requires a value getter. And over here, I'm just implementing the greater or equal than comparison, which I'm calling with getter. And instead of having a t value, I'm having a value getter value. So I'm requesting a value getter. And when I check if it passes, I'm going to get the value from this getter. And this value is now dynamic. It's not a static value. It might change because this will depend on the implementation of the value getter. Finally, you can see here that this is the same as before, and we're probably going to use the floating one, but I'm just making a floating greater or equal than comparison with getter data, which has a float value getter data. And again, subclass selector property and serialized by reference. And now it comes here, the example, and it's a very stupid example what I'm going to show you, but I hope you can see the power of all this. And what I'm going to do is go back to our example system. Let me type it here, example system. In here, I've created a new field, which is the a condition, and this is a move up condition. And this is what we've seen outside in our example SO. I am going also to cache here the move up speed, and we are going to use this for something. And in this example, I've also created a timer. This timer is initialized on enable. And here we have this property which gives us the elapsed time. And this is the value we want to get. And this is what I'm going to do now. And let me show you how I'm calling this. Over here, we are creating examples elapsed time getter. And yes, you can go as specific as you want over here. It's actually required for this kind of things. And this is going to return a floating value. Over here in the get value, we are going to perform several things, and some of them are not needed, but I just wanted to show you some extra restrictions that we can add over here. So we will first request one system, and this is the first step. We are interacting with our systems, and this is needed here because otherwise it would be impossible to interact with these systems. The only way to interact with these systems could be via the constructor, and could be done if you really want. You could actually do it. So through this whole deserialization over here, you could then via reflection check if this source is the system that you are looking for, because this is just done once. This deserialization is not done every time in principle. But in this example, I'm just going to get it a bit more simple, and we're going to check if the example is already requested or not. Otherwise, we're going to get it from the instance of our game instance. Then we are going to check this restriction, and this is just not needed now here. But let's say that you want to be even more safe, and you say, I only want that the system itself, the example system itself, can call this. And this sounds a bit stupid, but we'll see why this would work. This will work. But then you would check here and say, hey, if someone else has deserialized this, I'm not allowing you to retrieve any data, any value from the example system. And then I'm just also throwing an error. Because why? Because I don't want this to happen. So I want to fix this. I don't want this in the build. And this is also very important. When you don't want something in your build, just make it sure to log it somewhere clear. This should not happen. And finally, I'm just returning the elapsed time. Okay, so let's see what do we actually do with this elapsed time. Well, over here in our example system, I'm actually deserializing this move up condition with this simple line over here. And this is performing a lot of deserializations and complex and different steps as you saw before. But we will see this in the editor, in the inspector. But we are getting this condition. And what we are doing, we are also caching the move up speed. But what we are doing here is to check if the condition passes. If it doesn't pass, I'm not updating anything. And if it passes, then I will translate or move our transforms up with the move up speed. It's a very simple example. But this condition over here, which I deserialize with the example system, so this is the source, is requesting itself the elapsed time, which sounds a bit stupid, but it's just it could just request anything in our systems architecture, and in principle you would be able to get it, and that makes it quite powerful. So let's move to our inspector and see how do we actually set up all this. Let's see, I'll put it here. I think it will be more visible. And what we are going to do is to create a move up condition. I hope you can see it properly. Yes. There is only one implemented, so it's the only option I have here to choose, and I just add it here. Then we need to add our comparison, right? In this case, I have the integer or the floating. We saw these two different implementations. We're going to get the floating with getter value. And now it comes the funny part, right? We need the value, and we have this example elapse. So as you can see, what it's going to do when we deserialize this condition over here is to deserialize this comparison and deserialize this value getter. And we are going to compare to whatever, 5 seconds, let's say. So what will happen here when I play is that after 5 seconds, if everything went well, this should go up. Okay, so let's test this, right? I've added here a debug, I believe, that tells the time. So when we reach 5 seconds, it starts moving up. Okay, Seems to work, right? That's actually good. And as promised, I'm going to show you the example data asset file. What we can see here in the move up condition is that we have this reference. This is set in this way over here. We have the reference over here, which is says that it's a comparison condition data, and it comes from this assembly. And the comparison is also by reference. So we have the reference here, and this RID is resolved over here. And again, for the last one, for the value. I'm just showing this also because if it happened that you change something like the name of the assembly or yeah, whatever, and then this breaks and it tells you, Unity will tell you that the serialization doesn't match, you can always come to this file before closing the editor and things, because otherwise it will probably delete things and you would be able to still change the naming here and everything would work back again. Just telling you this because it can happen when you start playing around with this serialization via reference and not value. Just be careful, but you always have the data in the asset file or wherever you are saving it. Just, uh, just for you to know. And just before leaving, I always like to give you a more elaborated example of all this, and you can see here this is in my in the game I'm working on now, and this is match script data. This is used for creating, let's say, not cutscenes, but when you want to have like your match really directed and you want lots of kind of different things to be happening in a specific order and with a lot of restrictions and conditions. So here is where this kind of system could be used uh, and could be very useful. Yeah, you can see here that I have phases, which has different transitions and conditions, and you can see via the names what I'm actually doing. Now I'm just setting the player goal. I'm translating the camera. Over here, I'm also even requesting some labels. So I'm actually labeling my UI so I can access it or getting the position of this UI element at a very specific time because it can change. It is you can just extend it as much as you want, and you will just see that the more you work with it, the more familiar you get, and the more crazy you can get in what you do. Anyway, thanks for watching, and I hope it was useful, and I hope you enjoyed the video. And please, yeah, give me a like or subscribe. That always helps to keep my motivation on making these videos. So thanks again, and see you next time.